Indexes in database management systems come in a variety of flavors, and B-Tree indexes have multiple types too. They can be covering, composite, descending, clustered, or take other forms. In the database world, a clustered index is an index that stores the raw data of a table in an ordered format. Some database developers refer to clustered indexes as primary keys or vice versa, and a primary key is indeed a typical use case of a clustered index. In that regard, many developers will already be aware that a single table can only have one clustered index, and that's because data in a table can only be stored in one order. Clustered indexes are data structures that order rows in data pages in the same way that they are ordered in the index. The reason many clustered indexes come in the form of primary keys is because these keys often have an auto-increment parameter that makes null values inside of that column become automatically incrementing numeric IDs as values are inserted. With that being said, an auto-increment feature on top of a clustered index is not a necessity, but since many tables use a numeric ID field, the ability for the clustered index to increment values of rows automatically is an awesome feat. Since clustered indexes store data in the order of the data, inserting stored data is typically favorable too. All primary keys are clustered indexes. If the primary key is not defined and there are no unique indexes, MySQL would create or generate a clustered index on an invisible column and name the index gen_clust_index. To understand clustered indexes, think of those indexes as unique identifiers for each row in a table. Think of hardware IDs. Hardware IDs act as fingerprints of your hardware so the operating system can identify it as real. Hardware IDs are a set of letters and numbers unique to each set of hardware. Clustered indexes act in a similar way to hardware IDs, just inside the tables within your database. Clustered indexes have a couple of distinct characteristics unique to themselves. They store data in a specific order that cannot be changed, and every table has a clustered index. With that said, bear in mind that you cannot specify a clustered index per se, since your database will do that for you by either using the primary key, a unique constraint, or add one if you don't. To create a table bearing a clustered index, run a query like so. When altering a table, clustered indexes can be defined like so. Once a primary key is in place, it will be displayed with a pre-value in the key column once you connect it to a database and run a describe query. Here's how a clustered index is structured inside of your database. Now that you understand how a clustered index looks like, it's time to load a table with data and see which queries make use of the clustered index. As you can see, primary keys can be used just like B-Tree indexes can, but since they have a rather narrow use case, the instances where they are considered for use are also pretty narrow. The first query is using the clustered indexes in the details column. The second query is using the same index because it is the column after the where clause, and the like clause doesn't make it useless since there is a wildcard at the end as opposed to the beginning. The third query considers the index but uses none because the OR negates the necessity for it. If we would have an index on the username column, that one would be used instead. To conclude, clustered indexes order data in a table, and thus one cannot have multiple clustered indexes in the same table. Such indexes are often used to display automatically incrementing ID values when new rows are inserted, but if there are no automatically incrementing ID values, your database will use the first unique index as the primary key. If no unique index exists on a table, MySQL will generate a clustered index and name it gen_clust_index. Thus, a table has a clustered index no matter it's defined or not.